เอาไงเอาไง
เซนเซน
เสียงมันมาบ้างเป็นโหลที่มา
เซน
ไปไปยินอยู่มันกลับมาแล้วที่เสร็จอยากได้เป็นวันไหนระบุมาเลยได้คนสองได้คนชวนที่สองค่ะอาจารย์แปลคนนั้นยังไม่ได้แปลคนที่ไม่รู้แปลเป็นเป็นเวิร์ดมาตลอดเวลาซิเจนวิญญาณเอ้ยซิเจนตายยากจังนะอะไรเนาะเฮ้ยมันเร็วมันดีอร่อยได้ด้วยแต่ข้อเสียก็คือแสบมากตอนขาบอกคือแบบติดขีดแต่ว่าน่าจะขอกระเพ็ดน้อยนะชอบมากเลยอ่ะอะไรนะมันพี่สั่งกะเพราขอโทษหรืออะไรเพราะทุกคนไม่ได้ทำเอาคำไปเราเนาะใช่ไหมมันเตรียมไขมันแล้วฟังปุ๊บอร่อยได้ว่าเราแชร์สกรีนไหนทั้งหมดเราจะแชร์แค่ฝั่งนี้แต่ว่าเด็กแม่แต่ถ้ามีมันเป็นได้ฉันมาตั้งแต่ตอน7 โมงเราได้ความที่ดีแล้วไม่มีปัญหาว่าแต่ไหนๆก็ไหนๆแล้วเจนมีค่าเช็คเพื่อนที่รู้เวิร์กไหมเพื่อนของฉันคือแบบปฏิเสธความสะอาดใช่ค่ะมันหนักหน้าแบบมีเงินด้วยทำเป็นแบบถ้าไม่เป็นสิแต่เป็นก็เป็นสองคนดูถึงตึงขาดอารมณ์ปวดที่ถ้ามันยังอยู่คือด้วยสิเจนนะอยากเป็นความสะอาดสติได้ถ้ามีเป็น15จะไม่เป็นช่วยคนใช้ดีก็ไม่เป็นไรที่ติดแต่มันติด วันของสิ่งนั้นเขาจะให้เราทำมาก่อนปกติเพราะว่ามันไม่ได้สมองสารไม่ได้ปกติเป็นแบบไปสองพันเฮ้ยทำไมว่ามันสามารถลดความโกงของมันได้ถ้าฉันต้องใช้ตอนถัดมาต่อไปก็คือที่นี่มันเกิดการเป็นความแจ้งวัวนะแต่ที่แรกมันคือความสะอาดไม่ในท่านเรื่องมันมันจะมันจะไม่เป็นต่อต้องแต่ว่าเพื่อนเข้าเพื่อนมาแต่ถ้าเพื่อนไม่มาแต่แบบนี้เพื่อนจะหนักใจจริงดูความใส่ได้มันเริ่มออกแก่ต้องฮิวเฮ้ยดีมากเลยเอเลิฟฉันต้องการตัดเสียงแต่อ๋อคือน้ำพอดีที่เราดูใช่ตอนที่ทำร้านไม่ได้แต่เราสร้างหาเอชเอล โอ้ยพูดไม่ต้องเปิดไหมครับตอนนี้ไอ้ปลายเนี่ยเป็นเป็นท็อปิก for dealing with missing data that we call imputation. This is like a statistical method that is like a empire for clinical data. But you know that most of your data is that has a lot of in-deep analyze organization. Today I will divide the topic into three main issues. The first issue is like the method for dealing with the data, and the second issue is about I will show you about motivation example of imputation, and then we will work on multiple imputation. For the first issue about method of dealing with. Normally there are two approaches. The first approach is called complete case analysis, and the second approach that we will focus on today is imputation analysis. For the complete case analysis, as you see in your slide on the left-hand side, we have 6 subjects, and 2 subjects have missing value. The subject number 4 missing age, and the subject number 2 missing sex. For complete case analysis, these 2 records will be removed from the analysis. Even though there are another information from other variables, but they just missing only sex, or even though just missing at least one variable. That record will be removed from the analysis automatically. That we call complete case analysis. So the problem or the weak point of complete case analysis, it means that the sample size will reduce, right? So at the end, from 6 records, at the end you remain 4 records. It means that when you plan for analysis and estimate sample size, why we need to add more 10 or 20% for loss to follow. Also in this case, this is the drawback of complete case analysis. So this is the drawback of complete case analysis that we try to avoid, because at the end, even though you get the huge number of the data, and at the end you found that there's the large number of missing, at the end you will get like a small number of sample size and less power, right? And at the end you will get like the result is incorrect, or we call like a bias. So the statistician try to find the method to fill missing value. There are 2 approaches for replace missing value. First we call single imputation, and the second we call multiple imputation. For single imputation is like the traditional approach. Normally, the record that missing we always replace with mean. For example, age. You have that there are 3 missing value for age. So we calculate the age for complete case data, and after that we put the mean of that variable into all missing value. And for the categorical data, we will select the most common. For example, male and variable sex.
as you can see, most of the data are female. It means that the female will replace for missing value. So for the replace missing value with one specific value as mean or more, the weak point is at the end you will get like the understand the value, like underestimate the variance. As you can see in this example, if you calculate the standard deviation, the variation of the data for complete case, only complete case, you will get the standard deviation equal to 3.19. But after you feel missing value with the mean, it means that you try to feel missing value with only one single value, right? The same value for all missing case. So when we estimate the standard deviation, you will get only like a 2.6. Okay, standard deviation for complete data that's only 2.6. It means that the variation that you get after you feel missing value, you underestimate the value and then overestimate the precision. That is the problem of single imputation. So for today, we will focus on multiple imputation. The multiple imputation is mean that you have missing data set and then you try to simulate it the same like bootstrap that I explained to you at the yes, it's like the bootstrap process. Try to make a simulation for the data. This is like a missing data set and they try to simulate the data and fill the missing value for like many data set. And after that, we analyze the data for each data set. And at the end, we will pull them all together. It means that we have more than one complete data set based on imputation because we start with missing. And after that, we impute the data or fill missing value to get the new data set. But for each data set, you fill different value of missing based on the process of statistical analysis that I will explain later. And at the end, you get the complete case data set with different missing value. And then we work on data analysis for each data set. And at the end, we will get like a combine it all together and make a pool estimate. You will, at the end, you will get only one statistical analysis. Okay, and I will show you explanation. So strong point of the multiple imputation is like we creating multiple data sets, right? And then taking into account the sampling variation due to missing data. This is the benefit of multiple imputation. So for multiple imputation nowadays, it's like easy than the previous time because we have like the software that can help you to simulate the data. But however, you need to understand the concept and how to select the model to fill the missing value that I explained. Before I go into the detail of multiple imputation, I would like to give you an example of imputation. This example is a case control study that would like to examine the association between smoking and heart attack. The outcome of interest is heart attack, which is dichotomous outcome, and study factor is smoking. This is some correlate that might be confound the relationship between smoking and heart attack. Even though we focus on the factor of smoking with the heart attack, but this is observational study, right? You need to know that what correlate that should be related with the outcome. That we have A, gender, B, male, alcohol that we need to collect the data. And after you get the data, we summarize first before we go to the data analysis, we need to explore the data first. So after we explore the data, I found that BMI has missing value about 22 record that missing BMI. And the last variable is no missing data, just only BMI. And when we analyze the data, if you like to determine the association between smoking and heart attack, what equation or what model you will apply for? This is case control study. Logistic regression, yes, that's right. When we apply logistic regression, you know that 22 records are missing BMI, and the BMI is we need to include the BMI in the model, right? So at the end, when we analyze the data, the number of observations remain only 132. For the whole data set, all the data have 154. And when you put in the logistic regression equation with BMI variable, BMI is the one of the variable that you include in the model. And at the end, when we analyze the data, the number of subjects remain only 132. Okay. And as you observe for this equation, smoking is associated with heart attack. This is significant, right? And for BMI, still significant. And as you can see, age is non-significant with the heart attack. And after that, this number of subject as smoking BMI. And as you observe, age was not statistically significant. And then we apply the process of multiple imputation by simulate 20 imputation. It means that 20 data set we call number of imputation. For 20 data set, and then the number of observation is 154. And then after we get like a few missing value for BMI, as you can see, this is the result after we fill missing value. And then we analyze the data based on 154. The age become significant, but at the beginning, some like a 22 record and age are non-significant. But after you try to fill missing value for BMI, as you can see, the age is still the same, right? The data is not changed for age. And after we fill missing data for BMI, it means that the age that included in the model is 154. So the age is become significant. And if you don't care about the missing data, your result, sometimes your result is like incorrect, right? Because it changed the result. The age is not impute variable. It's like the variable that like a non-missing data. But when we analyze and combine with BMI, some record that you cannot find the association between age and heart attack. This is an example of benefit of multiple imputation. It's better than single imputation. Okay, and you like know the benefit of the imputation. The next step, I would like to work on multiple imputation with you one by one. There are many conditions, but I try to construct example 1, 2, 3, 4, 5 for different conditions. This is the step for imputation analysis. First step we call imputation step. First, you have like a incomplete data, the data that contains the sick value. And after that, the imputation step is like you work on bootstrap sampling. You have bootstrap data. And after that, in bootstrap data, you try to fill missing for data set of bootstrap. And after that, this is the blue color. This is the we call imputed data set. First, we have incomplete data set, just only one data set. And after that, you simulate the data. That we call bootstrap. It's like a sampling from the original sample. And then fill the missing value. It's like a random. For each data set, you fill like a different value for missing value. We call like a imputed data set. Imputed data set contain complete data, right? Because we fill missing data after imputation. We call, I use the word imputed data set. And after that, based on imputed data set, we work on analysis. And after that, we combine them all together. At the end, we call pooling step. There are three processes. First, imputation step to get the imputed data set with complete data. And after that, we complete like a data analysis for each data set. At the end, we will pull all of the results together that we call pooling steps. For the imputation step that I try to explain like a solid with the small data set. For the imputation, you need to know, you need to understand about what the meaning of EMI or imputation. The original data is missing with variable B and C, right? As you can see, they are missing with value. And for M1, it's like the first data set that you impute, right? Simulate the data. As you can see, the original data is exactly the same. 1, 2, 3, everything is the same. And for the first imputation, we replace the missing value for B and C with 4.5 and 8.5 based on statistical approach that I will explain later. And for the second imputation, the second data set, the original data set is exactly the same. And the imputed value become 5.5 and 9.5, which is different from the first data set, right? And then for M3, the original data is the same, but the missing value, that like the field missing value is different for other data set. This we call like we call M equal 3 imputation. It's like a 3 data set. We call M equal number of imputation for a single. This data set does only fill the missing value in the original data set. And this is the explanation before we go into the detail of imputation. As you can, that I explained before, original data with missing value, we call M0. M0 is refer to original data set, and M1 refer to first imputation, M2 refer to second imputation, and so on, if you have more than 2. And the number that you fill, we call imputed value. That we fill in the missing, for missing value that we call imputed value. And then after you get that is we call like an imputation. The process of imputation just only fill missing value for each data set that we generate. And the second step is try to work on the data analysis for each data set. If you have 3 imputation, you need to estimate. For example, if I apply logistic regression, I need to apply the logistic regression for first data set, second data set, and third data set. So the coefficients are different for each data set. And at the end, the third step, for example, this one I have M imputation and get the coefficient or the odds ratio for M value. And after that, this one, coefficient and standard error, we will like pull them all together based on the process or the concept of statistical analysis. At the end, you will get 1.258 for the coefficient and standard error 0.39. Put them all together. That is all the process of imputation. So for the imputation, we need the statistical model to help you to fill missing value based on statistical modeling. For continuous data, for example, if BMI missing or weight or height missing, you need to use the model that is for continuous variable, which is most common is linear regression. Another one like the interval regression, truncated regression, predictive mean matching that we can apply. For predictive mean matching, this is for the continuous data that non-normal distribution. We will apply predictive mean matching for non-normal distribution. The rest is like the same for normal distribution. But we have like a specific for interval regression that we need to limit the lower and upper of the value that I will show you an example. This is the model for imputed for continuous imputed value. And the second is for dichotomous or categorical variable. For dichotomous variable, you can apply logistic regression. For categorical variable, you can apply ordinal logistic regression or multinomial logistic regression. And for count data, you can apply Poisson regression to estimate the missing value. Okay, right now, I would like you to, that is the previous knowledge that you understand right now. If you will select the model depend on the type of outcome. Okay, this is the type of imputed value. Continuous, dichotomous, or categorical that have more than two groups of count data. Okay, we will start to work on data analysis. Use data command. This is based on the command MI command. For based on the MI command, we have 4 steps. The first step, we need to declare the data is for imputation or multiple imputation data. Use the command MI set. We start with MI set, and then we move on MI registration to let the program know that which variable is missing and which variable is complete variable. That we call MI register. And the third step, we will MI impute. It means that you fill missing value for each data set. And at the end, we work on the data analysis, MI estimate, that combine the process of data analysis and pulling the result. This is the main command that we will apply for multiple imputation. Okay. For the MI set, there are like many format for multiple impute data set. There are 4 types of data for MI. But however, I would like to show you about for each format. But at the end, we can select only one. Okay, I will start with the first format. The first format, the first style we call Y style. It means that you have this example have 2 imputation. For the blue color, it's like a original data. And for the imputed data is in the Y format. As like a yellow is like the first imputation. Because as you can see, the variable that are missing is only B and C, right? So for the imputed data is like B and C. B, sorry, there's one B and C variable, B and C. and 1 and 2 refer to multiple imputation. First, multiple imputation for B. Second, multiple imputation for B. And another is like the variable C, imputation 1 and imputation 2. If I have like a 4 missing variable, how many? If I have 4 missing variable and I need to impute 3 imputation, how many variable will add on? 12, right? 4 multiplied by 3. No, you will get more column, right? Equal number of imputation multiplied by number of variable. And you will get the extra column based on MI imputation comma. This is the variable underscore MI underscore mid. If equal 0, this refer to complete case. As you can see, the first subject, all of the data are not missing, right? This we call complete case or original data set. And for the subject number 2, underscore MI underscore mid equal 1. It means that this record is incomplete observation. Okay, this is we call Y format. And then I note for imputed variable for B and passive value for C. Because this example, B is missing value, we need to fill missing value. But for C is come from like A plus B equal C. That we call passive value for C. And the variable name is like automatically fit as like an underscore number of imputation and then underscore followed by the variable name. This is we call Y format. And I will explain to you later about passive value. For example, if you have weight and BMI and the variable weight is missing, we will impute or fill missing value for weight. And then you calculate the BMI after fill missing value. The BMI we call passive value. Okay. And the missing variable we call imputed value. Okay, that we need to fill. This is called style Y format for impute data set. And the second style we call F-long. F-long format is mean that the data imputation data set will be in the long format. As you can see, M0 is original data set. M1 and M2 is for data set number 1 and data set number 2. It means that if you have like 20 imputation, you will get more number of records, right? Equal number of imputation multiplied by number of observation, right? Because in this example, original data set you have 2 records, right? And for F-long style, you will have another data set. So for 2 records for the first imputation and another 2 records for multiple imputation number 2. You will get like a more data in like a more record in row, right? You will get a lot of data in row based on the number of imputation multiplied by number of observation. Another style we call M-long style. For the M-long style, the number of record equal the number of missing record. They will not like fill in the original data set for each imputation, for each imputed data set. Just only have only the record that missing. For the M1, the missing is only record number 2, right? So we have only number 2. And for M2, the second imputation have only 1 record for number 2. This is we call style M-long. And the last one we call F long set. It means that you will get the different data file. M0, the name is exam.dta. When you set the style at F long set, you will get the new data set equal the number of imputation. If you determine two imputation, you will get separately two more data set, and the name is exactly as underscore one refer to first imputation, and then exam. The file name is exactly the same, but just only add in front of file name as the number of imputation. This is F-long format. Okay, my question is, which style is used smallest memory in the computer? Why style F-long, M-long, and F-long set? M-long, yes, that's right. M-long is like a contain only missing record. When we work on MI set, you can apply any style that you want. But for me, I suggest to use M-long. Even though you use another style, at the end the result is exactly the same. But for M-long, it is like use smaller memory compared to other style. But sometimes we need to use other style if you would like to separate the data set into like a number imputation. But however, for this time, I suggest to use M-long style because it's like a smaller memory, like a occupy smaller memory in the computer. Okay. Because this is just only example that I show for you, right? But in the real practice, you have like a many variable and many record. The previous that I explained for how to MI set data or generate the multiple imputation is the first step to declare the data first. The second step, we need to register which variable is imputed variable, which variable is passive, and which variable is regular. There are three terms, three types of variable. First, imputed variable, it means that the variable that contains missing value. For the second type is passive. The passive is the variable that you need to calculate from the imputed value, as I show you an example for BMI. Or another one is like EGFR, for example, because you need other variable to estimate EGFR, right? So we need to fill missing value for each component and calculate the new variable that we call passive variable. And the last type of variable in multiple imputation is regular. The regular is the variable that contain like a complete data. There is no missing data on that variable that we call regular variable. Right now, you know three types of variable: imputed, passive, and regular. This I show you for this example to explain more about the meaning of variable type of variable. Variable A, we call regular variable, right? Because no missing data. And for variable B, we call imputed data because it's missing value that we need to fill. And for the variable C, the variable C comes from A plus B. So we call passive variable. No need to impute the missing value for variable C, but we need to calculate later, right? After we fill missing in variable B. Okay. this is the three type of variable. Okay, regular variable A, imputed variable B, and C is called passive variable because we can calculate later from A plus B. Okay. After the first step, we declare the imputation dataset. The second process, we need to register what variable is regular, imputed, or passive variable. And the third step, we need to fill the missing data based on MI impute command. And for the MI impute command, it depends on the type of missing value. We need to apply the appropriate model depending on the type of imputed value. I will start with the first that we call like a single variable, multiple imputation, but we try to fill missing value only one variable, that only single variable first. So if you would like to apply linear regression, we will use MI impute followed by MI impute regress, positive mean matching, MI imputed, MM. If you apply truncate regression, we will use MI impute truncate regress. And for interval regression, MI impute interval is for continuous. And for categorical data, or dichotomous outcome, dichotomous imputed variable, MI impute logic, MI impute O logic in ordinal variable, and then MI impute M logic of orthogonal. This I remind what type of model that we will apply based on the type of imputed variable. And this is like the option. For the F followed by the number, it's like you need to specify the number of imputation. And replace is like an impute value in existing imputation. And we need to set the initial number. It means that if I imputation and use initial number as you set, the result will be exactly the same. That I can like a repetition your process and get the same result with the same initial value. And false is the process with imputation even when missing imputed value are encountered. Sometimes like okay, I think it's better for complicated data set of missing. I will start with the first simple. Okay, before we work on like a practice with the real data. Right now, I would like to know that does anybody have question about field missing value? Okay, I will go through and we will practice together. For multiple imputation, we have two approaches: univariate imputation and multiple variate imputation. For univariate imputation, we will fill missing value only single variable, and then using regression model for each imputed variable. And for multiple imputation, it means that we will fill missing value for more than one variable. It's like in your data set, if you have 5 missing variable, we will impute 5 missing variable at the same time by chain equation. Okay. We will go to the first part about univariate imputation. this is the step for work on univalent imputation. First, we mi set style นะคะ the red is like the command นะคะ mi set style and then you can select y m long f long and m long set and then we register imputed variable นะคะ and then you fill missing variable and the later and another command is register regular variable. The important thing is we need to register imputed variable as regular. For passive is we can done later. And the third command after you set multiple input data set, register the variable and the last step is mi impute to fill missing value. Okay, we will work on together. Then this is like a summary นะคะ Okay, we will work on for example one นะคะ The example one is the data is missing. The missing variable is BMI. Okay, the BMI is continuous value, right? So we need to apply the linear regression to fill the missing value. Okay, I note at the bottom that you need to open the file mhard_1. Right now, I would like you to go to the data program, and then open the data set. mhard_1. Then you enter. First, we need to explore what variable are missing by using the command mistable sum. Mistable and space and the sum. It will show you like a BMI นะคะ the missing number observed OBS equal dot. It means like a missing value. And 132 is complete data นะคะ And according to 132 record, this is the minimum value 17 and maximum value is 38. Okay. So then you need to count. And you will get the number of observation equal 154. The first step, you need to mi set, right? Which style that we will apply for? M long, no? You can mi set M long. And then enter. And as you can look at my slide. First, we mi set M long. And the second command, after you enter, we need to mi register imputed. Mi register imputed. This is the command. And then you select the variable that is missing variable in this data set, which is BMI. Okay, you can select the variable on variable window, or you can type and then enter. They show like M0, 22 observation marked as incomplete. And then the next step, mi register regular. What is the regular variable? The leg ใช่ไหมคะ attack อะไรอีกคะ smoke age female อันนี้น่าจะเป็นhigh school grade นะคะแล้วก็ marital status แอลกอฮอล์ and then high class cigarette this is we call regular variable it's not missing นะคะ or you can only use this one only the variable that we can apply attack mode age female and high school grade นะคะ only 4 is okay because I use only 4 variable M status is not related to BMI okay just only 4 variables okay this is for the second one no for register regular variable and then enter ค่ะ and after that you use command mi impute and the pattern is mi impute followed by the statistical model for continuous outcome as BMI we will apply regress right you type mi impute following by statistical modeling which is consistency with the type of imputed value which is continuous imputed value right and after that you follow by the variable BMI regress and then follow by the imputed value that you would like to feel missing and after that equal and the left variable is the factor that you would like to feel missing value for BMI it's the same like you construct linear regression to predict the value of BMI based on heart attack value, smoking age, female, and high school grade. It's like a few missing value based on this variable. And after that, you comma and add. In parentheses is the number of imputation that you want. Normally, we will start with small amount of the number of imputation to make sure that this is correct, and then you can cancel. For example, I let you add for 10, and then you specify R seed, and then in parentheses you can set the number like any number that you want. It's like an initial number. If you send this to other statistician or other to your friend and use the same value, you get the exactly result, the same result. That they can repetition of your data. Mi impute replace, followed by the variable that we like to fill in missing value, and then equal followed by the factor that you would like to use as a predictor to estimate the BMI. So we have attack variable, mode, age, female, and high grade. Normally we will use the variable that did not have missing value as a predictor for predict the missing value. And comma add the number of imputation. Okay, I said 10. And then set RC to specify the initial number. And then enter ค่ะ enter variable attack ค่ะ type ที่ต้อง enter ค่ะ and get the result. If just only 10, just only use a minute. But if you say like 100, 1,000 people, and you got the same result. Now, if you show like the complete is 132, incomplete is 22, right? And then impute, fusing like a few missing value is 22. When you use the command impute, what? You will get the new variable on the variable window. You can look at tab, underscore MIM, and then enter. This will show you that 0 is original data, 154, right? You have 10 imputation. The first imputation fill 22 missing value, right? The second fill 22, because we use M long. If we use F long, all of the impute data set will equal 154, right? Because they combine or like a duplicate original data set. But for M long, you will get this one. And tab underscore miss, it will show you like 0 is complete data, 1 is the number of missing data, which is 22. Okay. If you like to look at the variable only M0, I would like to look at the distribution of BMI. You can sum BMI, if underscore MIM equal 0. Look at only original data set. The distribution of BMI only in the original data set 132, right? The mean is 25. Okay, but if you would like to look at the complete data, based on imputed data, you can use the command MI estimate mean. MI estimate colon and mean, and then followed by the variable BMI. MI estimate colon, because we would like to look at the mean, right, for BMI. MI estimate colon mean and then followed by the continuous variable. You will get the result. As you can see, imputation 10, number observation 154, right? This is like a BMI view, like a field based on missing value. And if you would like to look at the result of BMI, that field for each missing value, you can sum BMI if underscore MI underscore M equal, for example, I would like to look at number 5 data set. The mean BMI 24, minimum 70, maximum is 29. If I would like to look at number 8, as you can see, the BMI that field for each data set are different according to the data set, right? And then like we fill missing value according to the linear regression. So as you can see, the mean BMI for each imputed value are different. There are variations for each data set, and at the end we do them together and get for the overall number of observation 154. Then we get 25.
different result, always, was, our score and my, our score and qualify. Got different answer, whether it is because we are not like the same order. I mean, we not use by sort or sort, so that's why we got different answer.
Different answer is depend on and process that you MIQ and RC. That's why I said that if I would like to repeat the repeat process and use the same exactly data set like you, I need to use the same value of RC. This is we need to determine. But if you use differentiate, it's okay. The data like all of like we can use any data set and we need to declare what seed number or what initial number that we do. I use 1, 2, 3, 7. Different result of ปีใหม่เนาะI think but a little bit different that because we No, not necessarily. And it depends on the number of data set, the number of you like to include. If I use like a 20 imputation and use only 10, the 20 like you will get like we will get different result. But no problem because you need to declare what value that you use, what equation that you use. But the same concept. This is when the missing value is continuous value and we need to impute. Okay, fill missing value for continuous and clear. And I have this. And this is a summary of the command that apply. And the file name is at the bottom. And I put it in. And then move to the second example. Are you okay? Move to second example, and then you need to open the _2. If you like to save this data set, you need to save as, and then you mark as a impute data because the number of record are different from the beginning. Normally, when I feel missing value, I will save only original data set, and after impute, the data will like you will get more value. You will get more record, right? So I will save as imputed data. It means that if I would like to analyze the data according to the data set, no need to impute again. I will use open impute data and start analysis straight away. So you need to save as, save as data set now, save as, and then choose the name as like a _1 impute. That you know that this is the impute data, and then you can open it again, and that you would only estimate and fit equation that I will explain to you later. Right now we focus on the few missing value first. Save as to other data set as imputed. And then clear. And then I need to, you finish, you open the second data set under score number 2. And then we will start to explore the missing variables. You can use the command list table and then sum. List table sum. What variable is missing? Marital status. How many records that are missing? Seven. You can. This is categorical variable. You can calculate. And you can see that it's like a single, Mary, and word, which is order or unordered. Unordered. What equation we will apply to predict the single Mary word? M logic นะคะ multinomial because there are more than 2 categories นะคะ we start with mi set m long or if you want to use f long can do okay we can set mi set f long sure mi set f long and then enter. And what's next? The second step is mi register imputed. What the imputed variable? Marital status. Mi register impute marital status. And then mi register regular. And what variable that we need to estimate the marital status? I use this variable attack. Heart attack, smoke, age, BMI, female, and high school grade. In this data set, BMI are not missing, right? Because we use different data set, this is just only missing for marital status. So the regular variable is attack, smoke, age, BMI, female, and high grade, high school grade. Mi regular attack, smoke, age, BMI, female, high grade school, right? And then enter. The next step, we use mi impute, right? What equation we will apply? M logic, M logic. And then followed by the variable marital status. And then equal all the predictor, the regular variable that there are no missing variable to predict marital status. And then you need 10 repetition and set seed number. M logic followed by the imputed variable. and then equal the predictor that you want. Predict. Okay, and then comma specify the number of imputation I say 20, for example. And then set C. You can use any number if you want. And then enter. If I say 20, you take a little longer. And how many? Complete 147, incomplete 7, and include 7. Okay. Could you please tabulate M status if underscore M underscore MIN equals 0. This is for original data set, right? And then I would like to look at the MI number 3. As you can see, because we set as the F long, for each MI data set, they will include original variable, original data, and then few missing value. When you tabulate, you will get 154. Because we set style as F long, right? You will get like the data set equal the number observation equal number yes in original. It will add few for single marital status and divorce. And then as you observe, like the number for each category should be greater than the original data set, right? Because we start with data set and fill only 7 variables. Fill set only 7.
คือต้องเปิดเพราะว่าคือโบราณเองนะเสียแต่มันคือตรงนั้นเราดูกันสิคือว่าดูดีเซ็ตแล้วงั้นถ้าท่านเราได้จะรู้ไหมหรือถ้าท่านจะโบราณแม่เปิดหนังเพราะอันนี้แหละเราตั้งของแอนซีนแอนยังไม่กินรอไม่กินแล้วก็อันนี้ว่านี่มันเราของนั่นเดียวไปอะไรนี่และทีนี้เราก็ทำปกติเลยคือแท็กซ์ไลน์ถึงการซ่อมก็ไม่ได้ดีเพราะว่าสินค้าเราจะได้คอมพิวเตอร์ก่อนเราใช้มันเก็บไปเก็บเอา
After you can use the command. After you get the complete data, you can use the command mi estimate colon proportion and then followed by the variable categorical variable use mi estimate colon proportion and then enter. You will get the proportion of each category with standard error, but you will not get the number of observation, but just only the proportion. Because at the end we evaluate because this data set we use for analysis, not show the number of frequency, but we need to analyze the data. So it show like a mean or proportion. I think it's better that I give you break for 10 minutes or 15. No, you feel familiar with this command. And it is like a step by step. No? Okay, let's keep awake and walk around.
มันไม่ได้ต่างจากว่าเราเปล่า ในกรณีมันมีเยอะมันมีลำดับเป็นในความเลยแล้วก็เป็นแล้วมันแรงถึงของ2%ของจะเล็กมันเป็นคนแต่ว่ามันเป็นโปรแกรมสี เยอะมากในห้องจริงนะเนี่ยมันเป็นโรงพยาบาลโอ้ชิปโอ้ไอชิปพอร์ต identical port อะไรก็เราจะทำบ้านรอรอสามความรู้สึก
แต่ว่าเรา
ต่างกัน
We will move to the example number 3. The example number 3, you need to open the file mhard number 3 mhard 3. Don't forget to save this data set with other file name and then open mhard number 3. First, we need to explore which variable is missing by using the command table sum. What variable are missing? variable alcohol, and you need to try to calculate how the alcohol vary, how the data look like. Order or not order? Order, because the first like do not drink and less than 3 drinks per day and 3 or more drinks per day. It's like a sequence or order. Which equation that we can apply? Okay. Okay. First, we need to mi set m log or f log is up to you. Now it can do any style. After you set the format of data, mi data, the second step you need to register impute, which is the variable alcohol. And after that, mi register regular. For the regular, we have 5 variables, 1, 2, 3, 4, 5, 6 variables for regular. Then variable that enter, right? And after that, mi impute ologic, right? Use the command ologic. And then follow by alcohol, equal the predictor variable, which is attack smoking in eyes, female and and then specify the number of the imputation and seat number. And then you can calculate alcohol, if underscore mi equals 0, this is original data. And then for imputation number 5, add more variable, if you use it wrong. Is it easy? This is just only single variable. Okay, and next I would like to show you that if I would like to determine based on this data set, if I would like to determine like the risk of heart attack, based on the factor is alcohol consumption. Okay, you can use the command mi estimate and then colon. And then use the command logic, followed by the variable outcome, this is attack, yes or no, and then I dot alcohol. Okay, you can use, sorry, I'm going to use like a smoking or female first or female, I dot female. After you feel missing value, based on multiple imputation, the last command that we will analyze must be start with mi estimate, and then followed by the equation or like the statistical modeling that we need to apply, and then enter. As you can see, the number of observation is 154, and number of imputation is up to you because I set at 20. I set at 20 imputation. this variable is non-missing, right? So as you can see, average RVI larger MFM will equal 0 for regular variable. This is you get the coefficient. If you like to get the odd ratio, you need to MI estimate and then OR. You need to do like a two command. First MI estimate and then you fit the equation logic, right? And after that, you use the command MI estimate, comma OR to change the coefficient to odd ratio. This is for female. The female is not as like a gender is not associated with the heart attack. And if I would like to look at the alcohol, the effect of alcohol, you can use MI estimate. Select the previous command MI estimate logic. Attack is the outcome, the outcome heart attack, yes or no. And the factor that we would like to check the association is alcohol consumption. And then this is missing variable, right? And however, at the end, we get number of observation is 154 because the missing value we will like a few already, right? And as you can see, the average RVI or largest FMM not equal 0. And what I will explain later what the meaning of average RVI and largest FMI. This is refer to missing value. This not equal 0, but for non-missing value, this average RVI and largest FMI equal 0, right? Okay, and if I would like to look at the effect of estimate OR, MI estimate OR, so you can get the risk of heart attack. The odd ratio equal 0.64 and 0.61. But however, it's non-significant. This I would like to emphasize that after you use MI estimate, when you work on the analysis, you need to start with MI estimate. Cannot use like a logic without MI estimate at all. And I move to another data set about number of pregnancy, which is the number, right? So we will apply Poisson equation to fill missing value for the count number. I would like you to open the file in Heart4. The example that I show you, I would like you to look at the type of missing value. We will apply different model depending on type of missing value. Okay. Right now I would like you to open file number 4. First, we need to mix table sum. And as you can see, the number of pregnancy missing 10. You can summary in place or you don't tabulate in place. It's like a 0 and 1, 2, 3, 4. Maximum is 5. But around 10 record missing, right? And this is the missing variable is how data. So we need to apply for some. First, we need to start with MI set, M law. And then MI register impute variable. This is in pregnancy. And then MI register for regular. And then you select the variable on the variable input. Right now, this variable I'm not using. And after that, what else? MI impute. What variable that you would like to impute in pregnancy? So you need to use that for some. Impute for some. For some of what? Of the variable number of pregnancy. And then followed by the predictor. And then specify number of imputation and specify C. And then enter. And you got the same like me. And every time that the data give you a comment in the left color so they say like a missing value from the loop. This may occur when imputation variable are used as independent variable. Or when the independent variable contains missing value, you can specify option false. Okay, you can go back to the previous command and type false. This option is like a some variable might be missing variable, and it like allow to fill missing value like add a predictor. Type false after RC, no? And this one, as you can see, the number of missing is 10, but they can impute only 3. This is the file number 4. Okay, I think could you please clear first? I think I found some number. And then right now we are on M part 4, right? And this table sum only this variable and 10. All the variable are not in and text more and text. There are something other in this case. Oh, I see. This is the condition for male. Okay. Could you please tabulate the variable female? The female only 38, right? And the number of pregnancy should be only female. Male is no need to choose this variable. So on that, sorry that I forgot. So this one that I wish to focus on this slide. Sometimes that you need to specify or fill missing value for some condition, right? In this case, number of pregnancy male is like should not fill missing value for this variable, right? Would you please like open the file again นะคะ and start the same mi set long mi register impute mi register regular variable and however when you impute นะคะ and then you need to specify the condition after you add the number of imputation and RC you need to specify condition นะคะ use condition and then in the condition in parenthesis if female equal one is that I want you to highlight condition and then if female equal one and then at the end you get 100 like a 10 incomplete and 10 imputation. Okay. Yeah, right now you know like the statistical modeling for regression, right? M-logic, normal regression for more than 2 categories without order and ordinal logistic. Like a categorical variable has more than 2 groups with order. And what else? For some for number of events. And the last one that is like a interval regression. Sometimes we need to specify like a lower and upper for some value to like set the length for that continuous variable. Sometimes if we use regression, but at the end, probably you will get the number that is outlier for that variable. Sometimes we need to specify interval regression to specify lower and upper. So this for the interval regression there are like a different from other type of the model. So you need to we need to modify the standard syntax and specify the new variable name to keep the result of impute variable. We need to generate the new variable. And we need the variable for lower and upper. And we work on together. This I would like to show you that first we need lower and upper variable. For example, this is BMI. If missing variable, we need like a upper and lower. But for non-missing variable, the lower and upper will like exactly the same. That is like a non-missing value. Okay. After we will get this one, and I will show you how to do that. First, we would like to fill missing value for BMI with interval regression because we would like to determine the lower and upper of the imputed variable. If we did not specify, sometimes like we get BMI 60, that is not like a not impossible value, right? If BMI equals 60, so is it for safe? If we use interval regression to determine the lower and upper that can estimate using this plane. First, we need to generate the lower limit of BMI. The lower limit of BMI equal BMI and generate upper limit of BMI equal BMI. In case non-missing value, the lower and upper should be the same. This is for original variable. And then for missing record, we need to replace the lower limit with specific value that we set at the beginning. For BMI, we set the lower is 15, the upper is 14. It means that the value that we feel not out of this range. This is possible range of BMI 15 to 14. So we will replace lower BMI equal lower like a lower limit 15 if BMI equal missing. And then upper limit equal 40 because we set lower is 15, upper is 40 if BMI equal missing. So right now I would like you to open the file mhard file. Open the file mhard file. And then you miss table some around 20 this is 23 record missing BMI. If we set BMI as like based on regression, sometimes we will get like a lower and upper limit is incorrect. The result after filling missing value for BMI. So this is for safe to determine the lower and upper. So first we need to generate the new variable to keep the lower limit. You can generate lower, I use low underscore BMI equal BMI. In this case, if BMI not missing, the lower BMI equal BMI. And then upper BMI equal BMI. It means that the record that is not missing. This is original data, upper and lower. And after that, to replace lower BMI equal lower number that we set. The lower BMI we set 15. And then if the variable BMI is missing. For missing, we need to determine the lower and upper limit. And then replace upper BMI equal 40 or maximum that we determine if BMI equal missing. This is the first step to determine the lower like a lower bound and upper bound. And next, as you can see for the record number 1, BMI are not missing. So lower and upper will exactly the same. And for the second subject that BMI missing, so we determine lower equal 15 and upper or maximum equal 40. The next step, the same MI set in law. MI set in law. And then what else? MI register impute, which is what variable? BMI. And then MI register regular. It means the variable that is not missing. And check the whole thing. Okay. And then we MI impute for the interval regression. You need to MI impute interval regression ค่ะ INTREG and then followed by the variable the new variable that we would like to compute that like keep the value of missing BMI นะคะ this is the new variable BMI underscore impute the new variable in the database but normally I use the symbol is like underscore IMP is mean by the impute variable of BMI นะคะ and then the same equal นะคะ the factor that you like to predict the BMI and then comma the same add the first add the number of imputation specify initial number and then you need to specify LL and then in parentheses is the variable that keep the lower limit of BMI and UL specify the number that keep maximum value of BMI MI impute interval regret right for the variable BMI this is the original variable so we need to create a new variable equal predictor is predictor and then the same as number of the imputation and initial number and lower limit right LL in parentheses is what variable that we create low BMI right and then UL in parentheses is the variable upper BMI and then enter ค่ะ and then you look at 23 record you like a few missing value in 23 record and right now if you would like to look at the result you can look at MI estimate mean of BMI impute after this we will use the variable BMI impute if you use the variable BMI it contain the missing value then you look at this one so the mean as you can see the mean is 25 lower limit is not lower than 15 and upper limit not greater than 40 for sure you can apply lower regression or interval regression but however if you apply regression after you finish the process of imputation you need to check the distribution of the data that is in range of possible value one it is for interval regression that we need extra variable lower and upper limit that this is the multiple imputation by filling missing value only single variable and I show you that there are different types of missing variable so we use different statistical model to fill missing value next I would like to move to another issue that we call multivariate multiple imputation if still multiple imputation like do it more than one time right we call multiple imputation but right now we focus on more than one missing variable and when we use this approach we will use chain equation the chain equation is mean like you can use like many model more than one model at the same time before multivariate imputation as this one if we have like a p missing variable So the first imputed variable is x1. The variable like the predictor is other variable, but not x1. As you can see, the first equation x1 and predictor is x2, 3, 4, 5 until p. And in this in this equation, all imputed p value, we have p missing value. x2 is also missing value. x3 is also missing value. But we can use the predictor as missing value, missing variable, and it can feel missing for each other. The first step, they will feel missing value for the smallest number of missing value first, and then go to another step. It means that all variable will feel like a missing value. But we can use predictor as the missing value because it will like a step by step to fill each variable. And after fill missing variable, they will use that variable after fill missing to add in other model that can predict for other variable. And so as this one, based on this diagram or this table, on right hand side, this is we call imputed variable. All of this variable is like a missing variable that we need to impute. For education, the model on the column, the last column, use ordinal logistic. For the income, I use interval regression. For smoking, just only yes, no. Alcohol consumption, yes, no. I use logistic model. On the right hand side, on your right hand side is the model for predicting the imputed variable. And in the column, this is like a predictor to predict in imputed variable. As you can see, age is not missing, small is not missing. Height and weight. Weight and height is missing value, right? But weight and height can use as the predictor for education. That's why we call chain imputation. You can use missing value as predictor for other variable. And this is the pattern of chain imputation. The command is mi impute, and then you need to add the term chain, and then start with one equation for univariate model, and then the variable that you need to impute. Okay, I'll give you an example. For example, this data set, we have two variables missing value, age and BMI. So we need to impute age and BMI. And then how about type of missing variable, this one? Continuous, right? Which model will apply for? Linear regression, right? So when you use the command mi impute, and then chain, and then first we start with the model regress, right? And this model can apply for both age and BMI. So you have the variable age and BMI, and then equal. We use the same variable or only regular variable to predict or to fill missing for age and BMI. Use the same equation. We start define number m hat x is 0. For the simple case, first we need to mix table sum. Two variables are missing. So we start with mi set m log MI register impute age and BMI. For the first condition that I would like to show you is like try to fill missing value the same type and use the same predictor. Okay. MI register regular. And regular and attack the more age. Or not age, not age. Female and isolate. Use the same variable. This is for regular. And then MI impute. So we need to put in the parenthesis this equation for age and BMI. And then equal. Specify the model in the parenthesis and then followed by the missing variable, which is the same type, right? This is like a continuous and use the same equation negation, and then followed by the same predictor. Followed by the same predictor. And then add number of imputation. C. Two missing variable with the same type and use the same predictor. All of predictor is regular variable. And then enter ค่ะ sorry. Inside imputation. But we have more than one equation. MI imputation. ค่ะ as you can see นะคะ conditional model age and BMI with regression model and the same predictor นะคะ and then fill missing value and then based on this data set if I would like to use different factor or different predictor for BMI age we can try you can MI imputation again นะคะ for regression we use the variable for BMI Another way that if in case that we use different equation or even though the same equation but different predictor you start with MI imputation and for the first parenthesis you need like a replace with and then include first specify the equation for each missing variable regression and then comma include and then in parenthesis is the factor that you would like to predict. First, I would like to predict A and I use BMI as a predictor for age. This is the first equation The first equation open parenthesis replace comma include followed by the factor that you would like to predict age. Include and then put the predictor that you would like to use as a predictor for field missing for age, and then close, and then followed by the variable age. And then and after that, you need to open the new parenthesis นะคะthis is for the first equation for age เนาะ mi imputation first parenthesis contain of model comma include contain the predictor it can be non-missing or missing variable and then close and then followed by the missing variable that you would like to impute and then you open the new parenthesis and then specify the model and then include and then in the parenthesis นะคะ I use the variable as tag and then female for example female and age only this one to predict BMI mi impute chain นะคะ this is a little bit complicated I think it's better if you open do file can open do file can remember please go to window ค่ะ and then do file editor because this is very long command it is better to put the command in the do file นะคะ open do file and then I would like you to copy this one and I will show you this is better you can see นะคะ mi impute chain นะคะ and then the first this one for 8 and then you new like a new line นะคะ and then this one for first mi impute chain นะคะ for the first line นะคะ use statistical model ใช้ use regression and then comma include นะคะ follow by the predictor variable for predict for like a field missing value for age you close parenthesis first it should be double for the first and then include in parenthesis is predictor and for another parenthesis is for specify the model and close and then after that followed by the variable that you would like to fill missing value and then 3/ to say that this command is not finished and then you go to the next line the next line is the equation regression for impute the variable BMI it should be at the end right and then I use A right now age and BMI are missing right and I would like BMI to predict age and use age to predict BMI the missing predictor can use as the predictor for another variable and after that this is just only two variable นะคะ age and BMI and then you comma add number 10 and RC and then you need to add the option for or probably it's easy for me like add the number this one is easy the first line for the first variable to predict age. The second line to predict BMI and three slash, and after that comma, specify number imputation, specify seed number, and then false. To let the software use like a BMI and age as predictor for each other. And after that, you select, use the mouse to click line 1, 2, and 3, and then execute. The execute is like the second menu line on the right hand side. As the option replace because we use like the predictor as the missing variable, so we need to add in like a replace. Rice or over, rice over. Yeah, I don't know. Another way that I like you to do that. In my for that. Trying to show you that we can like an other verb, like a different equation, not necessarily to use the same equation or the same predictor for predict the missing value. But I remember that there are like the option that we need to specify. That we have missing value as the okay, it's better if you go this one first. Okay. Probably for this one, imputation replace. Okay, first we can ignore the missing predictor. For that, I will try to find out. I remember that it is that we can use missing predictor as the variable, as the predictor for other. Okay, for this time, in case that we have like if we can use like a different equation and different predictor, but just only not use the missing predictor first. I will try to check it for you. Leave first equation too small. This is you use the regression for age and BMI. The way that we type is like a replace for the first parenthesis for age without BMI and then for the second one replace predict BMI BMI is at the end First we specify the model comma include and then put the factor that you would like to predict the predictor variable in the parenthesis of include and then close and then followed by the missing variable. And right now predictor is only non-missing variable. And because I cannot remember that add some option that we need to put the missing predictor, put the missing variable as predictor. Okay, sorry that I should start this first, and then go. Okay. We try to use only the non-missing variable as the predictor, but you can use the different predictor for each equation. And for this example, we use regression to predict BMI and use regression to predict age, but use different predictor. Another example that I would like to show you with the different equation. The missing is BMI and smoking high tar cigarette. Another example is 5M hard 9. Okay, we can go to. Right now, I would like to show you like about multiple chain imputation that you can feel missing more than one variable. But for the first condition, I only use predictor, only non-missing variable as the predictor and use the same equation for age and BMI. And then I would like you to open another one. Another one, the file is number 9. M hard 9. First, you need to mix table sum. Right now we have age, BMI, and high tar cigarette. So for age and BMI, we use the linear regression, right? But high tar, I can need to tabulate just only yes or no, right? And the high tar smoke, high tar cigarette, that's only the people who have smoke, right? Not all patients, just only current smoke. That we will give like the condition for the cigarette. So we need to MI set M long first. And then MI register impute variable. The impute variable consists of age BMI and height cigarette. The height is dichotomous variable. And then for MI impute, you can go back to the do file. And this is for the first equation for age. We need to register อะไรคะ regular ใช่ไหม register regular right regular variable is attached small female and high school grade. This is for regular variable and then enter and then you go back to the do file. First we have regression for age and then regression for BMI with different predictor and then you add เนี่ยค่ะ the equation for logic นะคะ logic is for dichotomous outcome right and then include what the variable that we include okay attack and what else female and then smoke but however this condition this is for อะไรคะ heart attack ใช่ไหมfor high cigarette and you look at this one for logistic or for logic condition you need to specify each condition because high cigarette we use only the patient who smoke you need to specify the condition if smoke equal 1 after logic and then comma iterate for logic you need to set the number of iteration when estimate the coefficient so normally we set 100 comma iterate this is for logic equation that we need to use iterate and then 100 and after that augment the augment is for like some data set have like a zero event we need to protect the zero event so we need to add the option augmented it means that if they found zero event they will add 0.005 automatically to estimate the odd ratio so we need to add the option augmented and after that you need to include and then in parentheses is the predictor that you would like to estimate missing value for high time and the rest is the same add number of imputation and then initial value logic need to if condition should be before comma logic if what smoke equal อะไรคะ 1 เนาะ probably I can add this probably normally I try like a MI imputation and then I start with the new line to make it is easy when we write the program MI imputation is like the main command right and then new line for the do file we need to specify 3 slash to say that this is not finished it should be in the continue line and the second line is for impute age the third line is for compute BMI and the third line is for impute like a high time the high time secret we need to specify condition if small equal 1 and then comma augmented like the iteration นะคะ after comma iterate and then specify 100 and then augmented augment and then include and then followed by the variable three equations. It is better to use like a rule 5 because we need to separate between each equation. Right now we have 3 variables that is missing, right? So the first equation to fill missing value for age based on negation model and comma include and then in parenthesis is the predictor that is contain non-missing value. And then followed by the impute variable, which is A. And then I select 3 slash to let the program know that this is not finished. We will go to another line. Another line we start with the command we get and then include predictor variable to fill missing of BMI with negation model. And fourth, I use logic because high car is cigarette, yes or no. High car cigarette, yes or no, 1 and 0. And specify that include only smoking equal 1. And after that, comma, specify iterate for command logic. And then augment to protect the 0 event. And after that, include in parenthesis is predictor. And after you put all predictor and then close the parenthesis and then variable high time that you would like to predict. And after that, the same, and then you add the option false and replace. After that, you select the command from line 1 until the last and click execute. And then you get the result. Like to false and replace is like because we have like a many model. So we need to like let them try to fill all missing value. But normally I try to find out if I would like to use like a missing variable as the predictor. Need to use another option, but I cannot remember. I need to find it to find out for you. But right now in this case, or probably if you don't want to use the option replace, you can try delete, pause and replace, and let work it again. Delete, pause and replace, and work it again. First, you have 10 imputation, right? And after that, you impute it again with 10 imputation, and you look at the result right now, like a 20 imputation. I think like a replace and force, no need for this option. Force and replace is good in case that you use missing predictor, use the missing variable as the predictor. That I try to find out some problem that like that it doesn't work. นะคะ but right now you follow my slide number 61 first and I will show you another option that put missing variable for the predictorให้คุณ please clear this file first I can remember that one because I give you an example or assignment that let you work on imputation and use missing variable as predictor okay right now I would like you to open the last data file number 9 ใช่ไหม M hard number 9 okay and then could you please type miss table sum there are 3 variables right and then go back to the do file that we worked on before and then I would like to add the variable BMI at the first equation to predict age and add the variable age to predict BMI and then add the option false and then no impute this is the option that allow missing variable as the predictor so we need to MI set first นะคะ MI set MI register for missing and for regular option false and no impute it will let you use the missing variable as the predictor as you can see that BMI and age is missing variable right contain missing value and we can use BMI as the predictor of age and use age to predictor BMI this is the benefit of imputation and when you look at the result at the beginning condition model as you can see that the step for imputation will start with smallest number of missing values first and then go to BMI and then go to age and for BMI age as a predictor to predict BMI and we use BMI which is missing value right to predict age This is the option that we need to add. And okay, I think this is all we imputation. But however, before we finish this class, I will show you the starter file that I will let you work on imputation to guide you. Okay, and this is recommendation. Normally, we will try to use the variable that is like a predictor as much as possible. And then the outcome variable, because we have data set and we know that what is our outcome variable, right? The outcome variable should put in as like a predictor for impute to missing value. The outcome model should be in the model. And the number of imputation at least 20 imputation at least to reduce sampling error due to imputation. We suggest at least 20. But however, after we finish imputation, the next step that we need to analyze the data by the command MIStimate. As I explained before, at the end we will get only one, right? For this one, we need to consider how do we know that the number of imputation is enough. We set as 20, right? But we need to know that this is enough or not. How many imputation that we need. For this slide, we look at the number of average RBI. This value show like the proportion of increased total sampling variance due to missing information. This is the first value that we need to consider. Variable with large amount of missing in the imputation model will have high RBI. And the next value we call largest FMI. For this one, FMI is the proportion of total sampling variance due to missing data. High FMI can be indicate like the probability of that missing variable. So we need to determine the appropriate number of imputation is at least equal to largest FMI. So in this example in my slide, I set the number of imputation is 20. But when I use like the equation to construct the logistic equation to look at the association between predictor and outcome, I found that the largest FMI is 0.2518. It means that we need at least 25 imputation. So it means that if you start with 20 imputation and you found that this is not enough when compared with the largest FMI, so you need to MI impute again to add more number of imputation. This is not enough, so it is at least 25 imputation. So I run it again, and then look at this number. It will like a reduce. As you can see, this is based on this one. My largest FMI 25. So I need more imputation. And as you can see, if the largest FMI is less than number of imputation, it means like that now. This is to specify the number of imputation. And this is for our data set M-hard9. I would like you to fit the logic equation with the attack. Hard attack is yes or no, right? And then the factor that predict the hard attack. And then estimate OR. Okay, we can work on it together. After you finish the imputation for 3 variables, the next step, I would like to estimate the odds ratio. to show association of each factor with the heart attack. We need the command mi estimate after impute นะคะ mi estimate and then colon we need equation logic because attack is dichotomous outcome and the study design is case control study right okay we need to use variable age and female categorical variable we need I dot right and then BMI and then what else smoke I dot smoke and high school get to it this is one I dot high school get to it okay I need only 1 2 3 4 5 predictor to predict the risk of heart attack by using logic equation and then enter ค่ะ and then you look at the number of imputation I said only 10 imputation and the largest FMI equal around 21 right how many you get probably you will get different from me how many imputation you specify at the beginning 10 and how many largest FMI 33 yeah I think probably based different based on seat number that is it okay right now you need to go to we know that the number of imputation is not enough so you need to go back to the command imputation นะคะ and then you can add if largest FMI is 30 right you need more 20 so you can add 20 and then like perform mi impute again after you import like perform mi impute again do you get like right now 30 imputation and then you fit the equation again mi logic นะคะ again and then as you can see largest FMI is right now smaller than number of imputation now and I think this is the concept of imputation but I for this topic I give you an assignment that I give the data for you as KT data open MKT formula. That you got this one for assignment. Okay. This is assignment that I would like you to inform. First, you need to explore this table sum first. There are a lot for missing. Okay. I think it's better if I let you only some variable. First, I would like you to impute H. But group some H. Okay. H นะคะ แล้วก็ ABO group group this is categorical variable เนาะ this is continuous variable and SBS and this is for dichotomous variable. Okay, age, but group, HBS antigen. For another one is mode of dialysis. Yes. ABO group, SBS, mode. High แล้วกัน High ตัวละ5ตัวเนาะOkay, just only 5 variable นะคะ so it means that other variable that is missing you need to not declare for impute variable and for with this and for regular variable you need to check which one is regular. For example, say non-missing, the number of record is about 352. So the regular variable should be state type of donor is an immediate complication and weight is like a complete or regular variable. The regular variable consists of sex, weight, type of donor, immediate complication. And the variable that I would like you to fill missing value is age, blood group, HBS antigen. Mode of dialysis, I think I don't care about mode of dialysis, just only to report missing, not necessary. Probably I think could you please replace mode equal 3 if mode equal missing. I will make it like a regular variable. Replace mode equal 3 if mode equal missing. And right now mode is the regular variable เห็นไหมคะ so right now regular variable consists of sex ใช่ไหมคะ mode of dialysis and what else weight and what else? Type donor, and then immediate complication. This is the regular variable. Okay, this is the regular variable. Ah, okay. แบบนี้นะ regular variable นะคะ sex, mode of dialysis, weight, type of donor, and immediate complication. อันนี้ค่ะ AR acute rejection is mixing อะค่ะ still missing ค่ะที่ให้ยินดีวันนี้กันนะโอเค for the impute variable I would like you to impute มีอะไรบ้างนะคะ age ใช่ไหมแล้วก็บัตรกรุ๊ปบัตรกรุ๊ป and then height แล้วก็ SBS antigen บัตรกรุ๊ป SBS antigen แล้วก็ acute rejection and UTI แค่นั้นค่ะพบแล้วเนาะ continuous height ด้วยนะคะ มี age มีบัตรกรุ๊ปมีเรื่องของ SBS antigen AR acute rejection UTI แล้วก็ height this is for imputation ไม่อยากใช้หมดที่ว่าดีๆน่าจะครบนะเรียนก็ไม่ครบโอเค so this is for regular variable นะคะ and this is the impute variable that I would like you to apply chain imputation and the predictor that you use for field missing value apply regular variable also include impute variable as the predictor for other and the rest that you can ignore because I would like you to know how to work on multiple imputation นะคะ and you can use the predictor as regular variable or even though impute variable that can use as predictor the rest is I think is too much for you that's only 5 variable if you understand it is okay so in case that before you imputation if you found like some error from other variable that not related to my assignment you can drop from the analysis okay if it make error นะคะ for other variable นะbut if in the variable that I specify for you so you need to find out what problem or what error นะคะ and for other variable that I ignore it is better if you can delete for you work on because this is too much for you so the assignment for the assignment that I asked you I have document for you now in assignment. Okay. This one for assignment นะคะ My question ไม่ได้ปะMy question นะคะ Okay that we discuss only some variable that I talk with you not all that I set it for it's too much. Okay, I try to drop some variable. Just only focus on 5 variable that I tell you, and then how many missing data are there for each variable? You need to explain how many number of missing for each variable, and then specify what model you will apply for each input variable. For age, what model will you use? But group or even though acute rejection, you need to select the appropriate model to work on imputation นะคะ and then after that you perform multiple imputation, and after that I would like you to assess the risk of complication นะคะ after multiple imputation and look at the appropriate number of imputation. The outcome of this is like an immediate complication. The immediate complication is like a regular one. After you like impute like a few missing value, the next step that I would like you to use the logic command นะคะ to determine the association of the factor to complication. Focus only the factor that I give you about 10 variable for regular 1, 2, 3, 4, 5. For missing variable 1, 2, 3, 4, 5, 6, about 11 variable. Focus only 11 variable to construct the model for predict list of complication. เข้าใจไหมเอ่ยThis data set is about renal transplantation, and the aim of this research, we would like to look at the factor that associated with complication. So the predictor that should be related with complication is age, sex, mode of dialysis, and weight. All of the variable that I give it to you are about 11 variable. About 11 variable that I would like you to consider, not 11 here, 10, only 10 variable. Okay. Predictor that you need to consider. Predictor, we have one is variable age, right? And the second variable is sex. The third variable is mode of dialysis. And what else? Number 4 is type of donor. Number 5, this is predictor นะคะ Number 5 is blood group, ABO group. Number 6 is HBs antigen. Number predictor, other is like an active rejection. Should be have number 8 UTI. should associated with complication if the patient has this before ค่ะ and then number 9 weight and number 10 is height I focus only these 10 predictor and then the outcome of interest is immediate complication. Okay. So after you impute the missing value for some variable, according to the 10 predictor ค่ะ 5 of them are missing, right? So you need to work on imputation for 5 variable first. And after that, you fit the logic command or the logic equation นะคะ to predict use like a each factor you need to perform univariate นะคะ to look at each predictor associated with immediate complication or not. And after that, you select only the significant variable from univariate and put into the multivariate model that consists more than one predictor that associated with immediate complication. You have 10 predictors, 5 of them missing. So we cannot go to apply logistic regression straight away, right? Because you need to dealing with missing variable first. Okay, you need to dealing with missing variable based on imputation that I teach you today. And after that, the second step, you need to use MI estimate to fit the logic model. Okay. First, you need to work on univariate analysis. One predictor, one outcome. One predictor, one outcome. One predictor, one outcome. And look at which one is significant. For example, based on 10 variables, and then you work on univariate analysis. And you found that only 3 variables significant. So you put only 4 variables that is significant in univariate into multivariate to predict immediate complication. Okay, and then look at the largest number of FMI. If the number of imputation is smaller than largest FMI, you need more imputation. This assignment combine 2 approach. The first approach is about imputation, and the second approach is about logistic equation. So the first time that I let you know that I have assignment. So I tell you that I have assignment for prediction score, multinomial, longitudinal serval, and imputation. Right now, I think that I remove longitudinal data analysis. Okay. Right now, it remains prediction score, multinomial model, right? And then serval analysis. And for longitudinal data, I think I skip because I think you understand about the way to fit the equation already. So I focus on imputation, but add more for fit logistic regression to predict the immediate command. Then I will combine these 2 assignments and give you like the score. Or do you want the longitudinal analysis? No? Okay. Yes. For this data set, there are 10 predictors that we forgot, right? And 5 of them missing. It means that even though after you impute 5 variables and then you get the data set for imputed data set right now. So after this, even though we analyze something that not missing, we need to according to MI estimate. After that, even though you the variable the variable set are not missing, right? Not missing variable. When you fit the univariate, you need to base on MI estimate. Because right now you on the impute data set. I think it's better not use stepwise because a little bit complicated for stepwise with MI. So I just make you work on like a normal for only 10 variable univariate analysis. If like one of them like which variable is significant, you can combine it into multivariate. Because the stepwise is more complicated with MI estimate. Every time that we work on MI dataset, we have to like based on MI estimate. And for MI estimate, some command this is not cannot apply in MI estimate. You need to like programming something. I think it's better for your research that we can explore. But for this class, I would like you to understand the concept of imputation and how to apply. 'That I think right now we can avoid this process. If you use like the secondary data from database that common from the single value that we need to impute.
Exercise, you model.
The previous assignment that I try to like fill all missing data. It is better if you try to because the previous assignment I have the data that not much missing data and we try to fill missing data by open the data record for open EMR and try to fill missing as much as possible. ใช่ Yes, we need to the first table you need to show like how many missing data for each variable.
After we compute
Yes.
Either table 1 have to show like
how many missing value for each variable and then show the complete case for describe characteristic of the data, characteristic of the patient. But like show as it as the missing for each variable, but for analysis you need to apply that you will apply the imputation analysis to fill missing value before you start analyze the data or use the statistical model in practice นะคะ But for each assignment that I give it to you, we don't care about missing because I would like you to understand the model, multinomial model, longitudinal or serval analysis. I would like you to understand the basic concept of the statistical model first.
have to show if we already include we have still have to show
ใช่ If you like to use like the secondary data, like the common. However, you need to understand the previous concept about is statistical modeling, right? When you use complication, when you use M logic or ordinal logic, something like that. Chai ha.
That's all up here.
Ha. I will ignore this one and try to add a score for another assignment. I think it's too much. But however, if you understand, it's easy to use this concept for research. Try to understand the concept and try to link with your research patient.
Okay, so after the case of this one insurance, so this preliminary this motion the same shape. After the significant change in market and the comment is taking aspect and asset not budget. So after this one is we're going to change this whether it's large, is enough they will have to do it. So this is the source ofที่อาจารย์บอกว่าให้ทำมันเป็นคุณภาพมันชื่อแบบนี้ใช่ไหมคืออย่างในตอนที่เราถึงเราก็คือต้องในมาเลเซียโรงพยาบาลนั่นคือการเป็นชื่อแบบเขาใช้น้ำมาเลเซียแบบนี้มันใช่การที่เราในประเทศเซนต์เขาที่มาเป็นที่มันมีลงแบบหมายถึงว่าคอมพิวเตอร์ค่ะก็ต้องเรียนทางอะไรสิ่งของเราจะได้รู้ว่าซึ่งมันใช้อินทิลิเจนซ์แล้วก็พูดแก้ไว้จะมีเสียงต้องแข่งประดามจนขึ้นแต่ต้องแต่ว่าจะไม่ได้บอกตัวมันเองแต่เป็นนักศึกษาอาจารย์ว่าให้ฟังมาบอกเรื่องน้องเขาคิดว่าเด็กแล้วก็พอตัวสิการ ซึ่งในนามของเชื้อชอบเซเว่นเป็นผู้ตั้งเราเห็นน้ำเลย